All right, so look up at the screen, mathematicians. This should look very familiar to you. Well, one of you it shouldn't, because you didn't have Miss B last year, I'm pretty sure. But most of you guys, this should look familiar, because you literally did this exact same problem last year in, everybody remember scale copies? Woo! All right. Okay, well, I won't play this recording back for Miss B. All right, so I have a question for your table. So, we see our original figure is clearly labeled as original, right? So, I'm going to ask you guys. Oh, do you guys? Oh, they're up there. I don't know why they got moved. Yeah, they're over there. So, I've got two questions for you. First of all, are there any scaled copies to original figure A? I'm going to give you a minute to talk to the people at your table. And of course, if there are scaled copies, which the answer is probably yes, right? I can't ask you what the scaled copies are without also asking you for their scale factors. So let's see if we remember that. I'm going to give you just a minute. Y'all talk to each other, see if you got it. So your two questions are the length and the width of each of those rectangles after we cut the original piece of paper. And then what are the scaled copies, if any, of rectangle A, which is the big original piece of paper. Okay, so I'm going to record this part. So again, you don't need to worry about like writing this down right away. So I'm going to do what I call I'm going to give you the least important part of the information, which is the answer. Because what's the most important part, mathematicians? How you got it. So I'm going to tell you the answer, and I'm going to ask for somebody to pretty please tell me where that answer came from. So first I'm going to start with rectangle B. So what is the side length what is the length of rectangle B? How long is that, dear?
5.5 inches.
Okay, so where did we get 5.5? First of all, do we agree with 5.5?
Yes.
You should, because it's right. How'd you get it?
Dividing 11 by 2.
Okay, so the entire side of that was 11, and then we cut 11 in half, and we did 5.5. All right, so my next question for you, so did anything happen to the width? What's the width of rectangle B? It's still 8.5. So is B a scale? Well, I'm going to go ahead and tell you B is not a scaled copy. I'm going to write the word no. But why is it not a scaled copy? Yes, dear?
Because the 8.5 inches side is still the same, and that would only be a scaled copy if the 11 side was still the same as well.
I literally could not have said it better myself. To make a scaled copy, you've got to scale them by the same amount. So if we chop this 11 in half to get 5.5, we also needed to chop the 8.5. So wonderful, wonderful. All right, how about, so I'll go ahead and tell you that the length of side C is also, well, actually, we can probably agree about where we got that, right? Because we already figured out that's half of the length. How about the width of rectangle C? What's the width of that?
4 1/4.
So 4 1/4. First of all, do we agree with that? Yeah, you should, because it's right. Where did 4 1/4 come from? Where'd you get it from? Because you know that's the part I care about the most.
I divided 8.5 by 2.
All right, so the original length, correct me if I'm saying this wrong, was 8.5. So you cut 8 in half and got 4, and then half of a half is a fourth. Love it, love it, love it, love it, because you're right. Okay, so I'll go ahead and tell you that C is a scaled copy. But you know I don't care about the yes or no. What is the scale factor? If we already know that it's a scaled copy, what's the scale factor for C? Yes, ma'am.
1/2.
Okay, so we think that so relative to the entire piece of paper, so rectangle A, what fraction of the entire paper is rectangle C?
1/2.
Does it take up half the paper?
1/4.
We're really close.
1/4.
Yeah, exactly. So our scale factor, it takes up, because it takes up 1/4 of the paper, that means it's going to be 1/4. Okay, for D, we've got, I think you guys can see where we're going with this. So what's between D and E? Which one's actually my scaled copy? E, right? Yep. E is, in fact, my last scaled copy. And I got, for my length, I got 2 3/4, which is what you should have gotten. Where did I get 2 3/4 from for the length of rectangle E? Where did that come from? How did you get 2 1/4? Carrie, what'd you do?
1/2 of 5 1/2.
Oh, okay, so you took 1/2 of 5. That's what I did too. So I said 1/2 of 5 was 2 1/2, and then I said 1/2 of 1/2 was 1/4, and then I added them together. Yep. Love it. And E is going to be 2 1/8. Is E a scaled copy? Yes. What is it? So E's definitely a scaled copy. Well, I'll even prove it to you in just a second. What's the scale factor? What is it?
1/16.
1/16. Do we fit? So I agree, because we do 1, 2. If we filled up the page with E's, it would be like 1, 2, 3, 4, 5, 6, 7, 8, and then the other half would be 16. You're the first person that got that on the first try today, sir. Not that there's anything wrong with that, but that's awesome. All right, so Miss V would be very proud, and your day is going to be very easy for you today, because all you're doing today is adding a name to something that you already know how to do. You clearly know how to make a scaled copy. You clearly know how to determine if something, what the scale factor is. So all we are doing today is making scale drawings of other shapes, but we're not going to call them scale drawings. You know, my favorite thing that math people do is we give 90 words to exactly the same crap, right? So you already know how to do this. But instead of calling it a scaled copy, dun 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 dun, here is our new math word. Now we're going to call it a dilations. Okay? When you go to the eye doctor and they put those drops in your eyes, what happens to your pupils? They get bigger. What happens when you go outside in the dark? Your pupils, they get bigger or smaller or what? They get bigger. Okay. Exactly. So, hold please. So just like your eye pupils can get bigger and smaller, and that's a dilation, dilations with shapes can also get larger or smaller. It just depends on the scale factor. If you use a scale factor that's a number bigger than 1, as you guys remember, because you clearly showed you remember this, Miss B would be very proud of you. So if you do exactly the same thing. It's got a scale factor, it's proportional, you make a scale copy, all of that. We're just going to call it a dilation now instead of calling it a scaled copy. And there's one more addition too. So besides the fact that it's called a different name, instead of scaled copy, we're going to use the word dilation. There's one other thing that differentiates the scaled copies you were doing last year from the scaled copies that you were doing this year. Now, they are going to do something called defining the center. Okay, so if you had to take a guess, where's the center? P, right? Exactly. So P is my center. And all your dilations from now on, these are kind of big kid dilations. So I'm going to give you a little clue to help you get started. Because where you need to figure out, you need to apply the scale factor to the center. And here's what I mean by that. So I'm going to zoom in here. So you can see that you've got angle C is the smaller circle. Angle D is the enlargement of it. So I'm going to count using this grid is given here to you because it makes it a little bit easier for you to count units. So the distance, I'm just going to choose a grid line, and the distance from the center to the circle. That's what I'm counting. So that's 1, 2 units from the center to that smaller circle. So the distance from P to the exterior of that circle is 2 units long. Everybody see where I got 2 from, right? Because we're just counting the grid marks. So if I zoom out, you can see that angle, or that circle D, is that an enlargement or a reduction of a dilation? It's definitely an enlargement, right? On your paper, because I don't have it on mine, what did it say the scale factor was? It says to dilate it with what scale factor? You see on your class kick, where does it say you need to? Oh, it says what is the scale factor? My bad, that was dumb. Okay, I knew that. All right, so from the center to the smaller circle is 2 units. So let's see how many units it is from the center to the outer circle. So how many units is that? 1, 2, 3, 4, 5, and 6. So what's your guess about what the scale factor would be? How much of an enlargement was it? What do you got?
3.
It's 3, exactly. So since the enlargement, since D is 6 units away from the center, and since C is only 2 units away from the center, 6 divided by 2 means you had a scale factor of 3. So the only new piece of information that you are getting out of today is that we're calling them dilations now instead of scaled copies, and that now you're going to need to use the center as a reference point in order to enlarge and shrink things, in order to dilate them. You can have a big dilation where you make it bigger, or you can have a dilation where you make it smaller. You see the second problem that's on the same paper? So I'm going to give you one coordinate to get you started. So it says, here's polygon ABCD, and this time you're going to do the dilating. So in the last question, it asked you for the scale factor. You're going to actually do the dilation this time. And again, the center is P. I don't know why they always use P for the center. It must stand for something that I should probably know, but I don't know. All right, so I'm going to give you an example of how to do one of those coordinates. So I'm going to zoom in on coordinate C for no particular reason. That's just the one that's jumping out to me. So I'm going to zoom in and look at the distance from P to C. So let's count those little tick marks, those little boxes. So 1, 2, 3, 4, and 5. So my original point C is 5 units away from the center. So it just told me in the directions to dilate it using a scale factor of 2. So by logical reasoning, if my original was 5 units away from the center, how many units away is coordinate C prime? Because yes, we got to use prime notation because we are doing a transformation. So how many units, just take an educated guess, do you think if we're dilating it at a scale factor of 2 and the original is 5 units away, where might C prime be? 10 units away, exactly. So because your original was 5 units away, every time I say original, I keep thinking of like Kentucky Fried Chicken. I always want to say like extra crispy instead of the new one. Okay, so C was 5 units away. So if we're doing a scale factor of 10, that means it's going to be double. So your C prime should be right there. Instead of 5 units away, now it needs to be 10. So that will hopefully be enough to kind of get you started. So in big kid dilations, big kid scale copies, we are using the center as a reference point. So I'm going to shut up, give you a few minutes to try. There's 2 dilations for you to perform there. One with the scale factor of 2, and then you'll notice it also asks you, I don't have the picture on the screen, but it also asks you to add another one with a scale factor of 1/2. So use that little line tool. I see several of you guys getting up to go get the little plug-in tablets. That's a great thing for you to do too. I'm going to shut up and give you time to do this, but I'm going to show you the answer in a few minutes so you can check and make sure you're doing it right. I'm sorry, my allergies are killing me. So it's still called the pre-image because we're still doing a transformation, But are we doing a rigid transformation anymore? No. Remember, a rigid transformation stays exactly the same size and shape, right? So we're doing a transformation, but we're not doing a rigid transformation anymore. That's something to keep in mind for later. That'll be important. So I'm like, at least we have somebody, you know, like, my bad. All right. So if you,
waiting for,
you probably don't, guys, if you dilated the first one correctly, it should look like this. In a few minutes, I will give you what 1/2 should look like. But go ahead and try it yourself first. And I know some of you guys have already moved on to the back page, which is great. Good for you. You know, I err on the side of slow because I don't want to lose anybody, but you don't need to hang out and wait for the rest of us. If you can do page 2, go for it. Don't forget, this has been transformed, so it needs a tick mark, the little prime notation. If you don't have ticks next to it, you're not quite right. It's fine. Okay. So real quick, guys, somebody asked a good question that I want to make sure I get on the recording, number 1, and that the rest of you guys hear. Since it asked you to do the second dilation by completely changing the letters, you don't have to use prime notation if you're using different letters, okay? The reason you use the prime notation is if you have the same letters, then somebody can see which one was the pre-image and which one was the image. Oh, I'm going to work that one for the group in a minute because it's been blowing people up all day. So give me a second. I'm going to do that one. And several of you guys are already on the back for page 2. So before I show you what the 1/2 scale factor is, because I told you guys, like, don't wait for me. I'm being slow on purpose. But since a bunch of you guys are on the back, go ahead and flip over to the second page real quick, because I know this one's been messing pretty much everybody up. And then I can talk over you guys, but I'm going to, just so that you want, if you want to check your scale factor of 1/2, I backed up to the other page.
I'm kind of confused.
Sure. Hold on 1 second, dear. I'll be glad to help you.
Yeah, but you can make it. That's what you should.
I could be like this.
Like you have to.
I mean, I've always been. That was like one thing I've always been pretty good at.
Okay, since these are fractional units, mine are kind of like just a decent estimate.
Do we have to have any more points on the side besides like the one?
I'm going to give points for explanations. So, guys, oh, shoot. Oops.
Do I need to raise my hand?
No, because I'm going to go through it and check all these. All day in classes, people have had a hard time with this one. So flip over that back page real quick, because I'm going to go ahead and work the hardest one for you and give you a little bit of advice about how I would attack some ones like this when they don't turn out to be whole numbers. So everybody look at the screen. Even if you think you know what you're doing, a whole bunch of people have got, and even if you got the answer right already, I might be giving you some advice that'll make your life a little bit easier, I think, anyway. Okay, so E and D are the two that people have really gotten stuck on. So I'm going to look at, so I'll skip down to D. Guys, give me 1 second, y'all. All right. So if the original was 12 centimeters, and in D, it's 18 centimeters. Obviously, if it is a dilation, it is going to be a scale factor larger than 1 because it went from 12 to 18. To figure out that scale factor, what you can do is just say 18 divided by 12, which now that we're in big kid math, we know that division is another way, like a fraction is another way to say division, right? So here's something that's kind of nice. You don't have to do 18 divided by 12 and then get a mixed number or a decimal and turn it back into a fraction. All you have to do, friends, is simplify it. So look, there's your scale factor, 3/2. In algebra, we like fractions, especially when we do slope and all of that. That was a lot easier, if you ask me, than doing 18 divided by 12, then turning around and making it a decimal. Because remember, a fraction means division. So now, of course, we don't know for sure that it's a scaled copy, other than the fact that you guys probably just already typed it in there and know it's right. But here's how we can verify it, though. Because now I need to check with the other side, because remember, it has to be proportional. So that means I would have to do 4.5 divided by 3. And for those of us with our basic facts, because 1.5, in my head, I'm thinking of 45 divided by 15 instead of 4.5 divided by 1.5 because it ends up being the same thing. So 45 divided by 15 is 3, and then 3 divided by 1.5 is 2. So see how you got the same scale factor? That's how you know they're proportional, and it could therefore be a scaled copy, which also means it could be a dilation. So if you can divide your image by the pre-image and you get that same scale factor, so that's one way that you can do it. So that's what I would do. I wouldn't divide them into decimals and all that. I would leave them as fractions because it really does make it easier for you. For the rest of these, of course you have, because you're a machine. Hold on one second.